So in the last video, we talked about what stoichiometry is and how to solve basic stoichiometry questions with the BCA table method. So essentially what we learned to calculate the number of moles of a product when given the number of moles of a reagent or vice versa. So essentially, the key idea from the last video is we can use the number of moles of the given substance, usually given in the question. I'm going to multiply that by our mole ratio, which is the number of moles of the substance that you're trying to solve for, over the number of moles of the given substance. Okay, so basically this mole ratio is indicated by the balanced equation. And in the last video, I also mentioned that the most common type of questions you are going to work on is the mass-mass stoichiometry and molarity-molarity stoichiometry questions. Essentially, this may sound very complicated, but it is really not, because all you need to do is to make sure everything is in moles first. So the given substance, it's in number of moles. Even though the question could give you in grams, could give you something in volume, could give you something in grams and volume, you basically convert everything to moles first before you construct the BCA table. And then after you've done that, you can convert everything back to grams, volume, whatever the question is asking you. So let's take a look at an example here. The canvas has 23.5 grams of copper 2 chloride and lots of aluminum foil. How many grams of each product can the canvas produce by reacting the copper 2 chloride with the aluminum foil? So again, don't forget our key steps here. So step number 1 will be to write the balanced chemical equation if 1 is not given. And then step 2 is to figure out the mole ratio based on the equation. So I know that the ratio between copper 2 chloride and copper is 3:3. In other words, it's just 1:1. And the ratio between copper 2 chloride and aluminum chloride would be 3:2. And step number 3 here, surprise, it would not be the BCA table. Because in order for you to put everything in your BCA table, you need to make sure all the value is given in number of moles. So because in the question here, the value, the amount of copper 2 chloride is given in grams. So what we have to do first is to convert a number of grams into number of moles by multiplying by dividing basically the molecular mass of copper 2 chloride. And that will give you 0.175 moles of copper 2 chloride. Then after you've done so, you can put your information finally in your BCA table, right? So again, before I can assume that my aluminum is in excess, and copper 2 chloride have 0.175 moles as calculated. And before I combine these two reagents together, I should have 0 moles of aluminum chloride as well as 0 moles of copper. And then next, I can take a look at the change here. What I will have at the end of the reaction will be, I will use up all of my copper 2 chloride. So minus 0.175. As for my products, I will have, for example, my aluminum chloride, I will have 0.175 moles of the copper 2 chloride multiplied by the mole ratio between aluminum chloride and copper 2 chloride. And as for copper, I will form 0.175 multiplied by, again, the mole ratio between copper and copper 2 chloride. And that will give me 0.175 moles of copper produced. So essentially, after your reaction, after the whole reaction is finished, you are going to just add the before and change column together. So for copper 2 chloride, again, you're going to use it up, so you have 0 left. And then for aluminum chloride, you are going to have 0.116 moles of aluminum chloride. So this is because when you basically plug it into a calculator, and this is what you get. And as for copper, I will have 0.175 moles of copper at the end of the reaction. So once I find out how many moles of aluminum chloride and copper are being produced, I will have to basically convert them back to number of grams, because in the question, I'm asking how many grams of each product will be produced. So let's start with aluminum chloride. We have 0.116 moles. We're simply just going to multiply by the molar mass, and we have 15.5 grams of aluminum chloride. Same thing here with copper. We have 0.175 moles of copper multiplying by the molar mass of copper, and that will give you 11.1 grams of copper. So the final answer here is, if you have 23.5 grams of copper 2 chloride, you should be able to produce 15.5 grams of aluminum chloride, as well as 11.1 gram of copper. So the summary of this video essentially is, the key steps here, you would not lose them, right? You write the balanced chemical equation first, and then you're going to figure out the mole ratio based on the balanced equation. Then you're going to construct a BCA table. However, when the initial amount is given in some other units instead of number of moles, you will have to convert everything into moles first before you put everything in your BCA table. And then afterwards, you can convert everything back to grams, volume, etc., depending on what the question is asking you. So that's it for today's video, and stay tuned for the next one.